So our analyzing function notes from, so it would have been Thursday for B cohort and then Wednesday for A cohort. Some of the things for important pieces of graphs, so especially when you look at graphs that look like this, some really weird looking ones with a bunch of different sections. Some of the information we want from the beginning is how many sections are there, the number of sections. We want to find and determine the slopes of them, so that's the steepness. How are they slanted? We want to know the independent and the dependent variables, so what's actually going on in the story. We want to talk about any y or x intercepts, y-intercept mostly. So this is what we want to look at when we go through. Looking at our first graph, down here on our x-axis is going to be time in seconds. So this is our x-axis. This is our independent variable. The independent variable is always found on our x-axis, meaning our dependent variable is over here. And for this particular problem, it's going to be questions answered. All right? So a couple of the big important pieces start right here. This is our point. It's on our y-axis. This is our y-intercept. Represents our start value. It is 0, 0 for this problem. What that means in the context of the story, this 0 goes with x, this 0 goes with y. Therefore, at 0 seconds, we have 0 questions answered, which makes sense if we're taking a test or anything like that. This graph is broken into 1, 2, 3, 4, 5, 6, and 7 sections. We're going to go through and we're going to find the slope of all 7 sections. Before we do that, I want to know what sections are increasing. So as we read the graph from left to right, just like a book, we don't read it from right to left, always left to right. Which of these sections are increasing, are improving, are growing up? So starting here, we've increased to our next dot, so section 1 is increasing. Section 2, we have not increased, so we're not going to include it. 3 has an increase, so we're not going to include it, but we're going to include 4 and 5, but not 6 and 7. We're going to include a few of these sections as decreasing. So those sections would be 2, 6, and 7. That leaves our last one, number 3 here. Section 3 is known as a 0 slope. So these are all of our slopes. 1, 4, and 5 are all increasing. We're improving from where we were. So we went from 0 to 2. We went from 1 up to 4. And then we went from 4 to 6. We've increased. I don't care about the x value. If you notice, we're always moving to the right. We're always increasing here. Our independent variable doesn't really matter so much. It's how are we changing with our y, our dependent variable. We're going to go through now. We're going to find the slopes of each one of these sections. So our slope, remember that's our rise over our run. From point A to point B here, we have to rise 2, run 5. Section 2, we have to go down 1, right 2. So down is negative, which makes sense. The first section is increasing, that's positive. We see it's positive. Decreasing, that's negative. We see that it's negative. Section 3, this is our 0 slope, and that's exactly what we see with our rise over run. From C to B, or C to D, I should say, we rise 0, but we run 2 spaces. Section 4, we rise 3, run 2. Again, positive section, positive slope. 5 is positive, so we should see a positive slope. We rise 2, run 4. Now this fraction is different than any of the other ones that we've encountered so far. We can actually simplify this one. Because we can simplify this one, 2 over 4 becomes 1 over 2, because I divide both these by 2. I can actually see that slope present in the graph, up 1, right 2, and I land right back on the graph. It's that consistent pattern. You got to think of it like a staircase. We want those steps to be exactly the same over and over again. We can have 2 little steps like this, or 1 big step, but it gets us to the same spot. All right, section 6, down 1, 2, 3, 4, right 3. And then section 7, down 2, right 5. Our second graph here, one of the big things that's different about it is our start value right here, our y-intercept, is not at 0, 0. It's at 0, 5. So in this problem, which is time in minutes, and over here is distance, we have 5, so let's say distance in feet. We have 5 feet already in distance at time 0, at 0 minutes. So if we're running a race, we have a head start. Then immediately we lose distance, we gain it, nothing happens, it's at 0 slope. Lose that distance, gain it, lose, and then gain it back. But for this graph, I actually want to look at problems like this, f of 5. So before we can actually answer this question, we have to know what the question is even asking. What this one is asking for, since we've plugged in an input, we've plugged in an x value, we're going to find 5 on the x-axis. So here's 5. We're going to come up to the graph and we're going to see what number the graph is telling us. So right here, it's telling us 2. We plugged in and we get out. This question right here is asking us at 5 minutes, what's our distance? If we do that again, let's say f of 20, I plugged in 20, so I find 20 on x, and it spits out 3. It does not have to be these points. It can be any number that we might want to know. Let's say you're looking at this and you go, I want to know at time, 10 minutes. How much distance did I have? So you find 10 minutes. We come up to the graph. It's not a perfect whole number, but that's okay. We can estimate. We come over here. Oh, that's not a very good line that I'm drawing there. Let's try it again. Oh my gosh. I'm going to let the computer draw the line for me because I apparently can't do it right now. So perfectly straight right there. I'm going to erase some of this because it's getting a little cluttered. All right. And so we've now encountered our y-intercept right about there, between 4 and 5. So it's not exactly 4, not exactly 5, somewhere in between. I'm going to estimate maybe like 4.25 on this one. I don't think that's halfway so much. If I were to erase that red dot now, I don't think that's about halfway in the box, so 4.25. We can use that to find any output for any input. We just have to pick a number. If I wanted 15, there's where the output. If I wanted 22, there's my output right there. It's not a very good line to it, but that's what it is. For our last graph here, I want to talk about problems that look like this. F of x is equal to 5. Want to look at the difference between this problem and one from the previous slide. Look at the difference. The 5 is within the function notation, while over here the 5 is what's being equal to. So in this one, that was x. We were looking for y. This one, we know what the y is. We don't know what x is. So we're going to approach this problem backward compared to this one. So where we went and found it here and went up, we're actually going to find it here, and we're going to go across. So this problem I have written in blue is basically saying, at 5, what were my x values? Looks like they were 7 and 16. Let's try it one more. Let's say f of 3. Not that, sorry. We did that. I was looking at the one above. I apologize. F of x is equal to 3. Subtle difference, but speaks volumes. So instead of finding 3 and coming up, I already know that 3 came out. So I need to find the input. So this one, there's actually going to be a bunch of answers. So there's one right there, one right there, one right there, one right there. So let's start with this left one. It comes straight down. It's a little bit between 3 and 4, not quite halfway. So I'm going to say that one of my answers is 3.25. This next one, not quite 8, more than 7, maybe 7.7. This one, perfectly 15, and this one, perfectly 18. So the three things when we're looking at these weird graphs, these questions are asking for your inputs, our x values. These problems gave us the input, we want to know the output, and then finding the slope of every individual section. So if we go back and kind of clean this one up, we'll do one last one. We can look at just this second section right here. The slope, again, we go from one dot to the next dot. So this one's up 3, right 2. Simplify it if you can. So that was our analyzing functions day.